Hello, it's Lynn. All right, completing the square. So what we need to do is we need to figure out how to solve something when we can't actually factor it. So in this problem right here, we don't have factors of -3 that add to 4, so we would be kind of stuck. So there's two ways you can do it. One is completing the square, and the other one we'll learn in another video is using the quadratic formula. So first of all, the object is to get this to look like a perfect square trinomial. And my first question is, what is a perfect square trinomial? A perfect square trinomial happens when we have something like x plus 4 squared. Again, that turns into a trinomial when we FOIL that out. So that would be x squared plus 4x plus 4x, which is 8x plus 16. And then say we had something like x minus 5 squared. That would be x squared minus 10x plus 25. Now what I want you to do is look at the relationship between these two numbers, the 8x and the 16 and the 4. And a lot of people will notice, maybe after a little looking, that if we have a 4 here, this is doubled, and if we have the 4 here, this is the square of 4. Same here with 5. The -10, if we cut it in half, we get to -5. And if we square the -5, we get 25. So what we want to do is make this into a perfect square trinomial. So clearly that -3 doesn't work. So the first step is to move that -3 to the other side. So we're going to go x squared plus 4x, and then our object is to figure out what goes in this blank to make it a perfect square trinomial like one of these. And then so this is going to be, since we added 3 to both sides, it's going to be equal to 3. Now this is my hint. A lot of times the book doesn't say this. If we add something to this side, we need to remember to add it to this side. So I always like to put plus box, because inevitably I'm going to get so wrapped up in figuring out what this side should look like that I don't remember to add the same thing to the other side. So right away, I'm going to put a box. So notice, if we have this trinomial and we want to turn it into this, we know that this middle term, which is this 4x, half of that goes right here. So my next step is to make this, figure out what that perfect square trinomial would be. And so half of 4 is 2, so we're going to do plus 2 squared, and then we notice that if we square this number, it will be that box number. So this would be like the box number. So we square that. So what I think of it is we take half of this number and then we square it to get this number. So we're going to get a 4 here and we get a 4 here. So now we have 7. The beauty of this is that now we can just take the square root of both sides to get rid of this squared, because this squared sort of locks these parentheses. So I'm going to take the square root of this side and the square root of this side, remembering that I need a plus or minus in front of that square root sign. So the square undoes the square root, so this just ends up being x plus 2, and that equals plus or minus the square root of 7. And now we just can solve for x because it's out of the parentheses. So we're going to do -2, -2, and x equals -2 plus or minus the square root of 7. Now we have two answers, a -2 plus a root 7 or a -2 minus the square root of 7. And since these are not like terms, we can just leave it like that. If this was plus or minus just a plain 3 without a square root, then we would actually get two individual answers. All right, next I'm going to do one more example that has an extra little twist to it. Okay, ta-da, clear board, new problem. What is different about this problem? The things that's different about this problem is that we now have a coefficient in front of the x squared. And if you remember from when we were factoring, that was always a little more difficult. Completing the square does not work if you have this coefficient in front. So what I like to do is first of all move that 1 over. So we have a minus 1 on both sides. So we have 3x squared minus 12x, and I'll say plus a box because I just want to get used to that, equals negative 1 plus a box. Now, what we need to do here is get rid of that 3. And since there's an equal sign, we can divide everything by 3. And it's nice that this is a 12. Not so nice that this is a 1 because we get a fraction. But now this turns into x squared minus 4x plus a box equals negative 1/3 plus a box. Now this is legal. We can complete the square here. This is very similar to the one that we just did before. We say, okay, what perfect square trinomial are we going to make this in? So I write down what would be the perfect square, and it's going to be x, and it's going to be half of that term again. This is a negative 4, so that means this is a minus 2. Minus 2 squared is still a plus 4, so there's a plus 4 here. So now this equals, and we're going to change this into thirds. So we divide this by 3 and multiply by 3 on the top, so this is 12. So this is going to be 11/3. Now, again, this is a perfect square equaling just a number, so we can take the square root of both sides, remembering the plus or minus part. And so we get x minus 2 equals plus or minus the square root of 11 over 3. So x equals positive 2, so we're going to add 2 to both sides. 2 plus or minus the square root of 11 over 3. And you remember from earlier, we have to simplify the square root. So let's just look at the square root of 11 over 3. That's equal to the square root of 11 divided by the square root of 3. And I've talked about the math gods before, and they don't allow us to have a square root in the denominator, so we need to rationalize this denominator. So we multiply this times square root of 3 over square root of 3. So we get the square root of 11 times 3, which is 33, all over 3. So our final answer for this one will be 2 plus square root of 33 over 3, and 2 minus the square root of 33 over 3. So the hint in this part is you need to divide by whatever the coefficient is of the squared term before you can complete the square. Another hint here, if this is an odd number, you're going to get a fraction. You're going to, like if this was a 5, you would have 5 halves here, or 2.5. Then you'd have to square 2.5 and add it to both sides. So be careful when you do the fractions, but the rules all stay the same the whole way. So have fun completing those squares. Remember to write those squares in, completing the square, write the squares, don't forget.